Hi, this is a video to give you some examples on how to use force diagrams or free body diagrams to solve problems about how an object is moving. The first example says, your Thanksgiving Day turkey is at rest on a beautiful platter. It has a weight of 98 newtons. A knife exerts a force of 2 newtons downward on the turkey. Determine the normal force that a platter is exerting on the turkey. Draw a free body diagram. So let's draw a picture. I'm going to draw a turkey and approximate its shape to be an oval. Below the turkey is a platter. Okay. And we will now start drawing in the forces. Remember, all of the forces come from a dot in the center of the object that we're looking at. The turkey, we've got a weight of 98 newtons. Remember, weight is a measure of gravitational force. So the force due to gravity is 98 newtons. Just as an aside, remember, force due to gravity is equal to an object's mass times the acceleration due to gravity. So if the force due to gravity is 98 newtons and force due to gravity is 98 newtons, the acceleration due to gravity is 9.8 meters per second. That means the mass of our turkey must be equal to 10 kilograms. It's a pretty big turkey, about 22 pounds. All right, now we also know that a knife exerts a 2 Newton force downward on the turkey. Okay, that force is also downward. We also want to draw it coming out of the center of the turkey. All forces come out of the dot and the center of the turkey, but it'll be a smaller force vector. Whoops. A smaller force vector. Force due to the knife is equal to 2 newtons. Sorry, it's a little sloppy. I need to get a stylus. And then we also have a normal force. So if these were the only two forces acting on the turkey, there would be a net force downward, meaning the turkey would be accelerating downward through the platter, through the table, and Thanksgiving would be ruined. We know it's resting still on the table, so there must be a force balancing these out. And we call that balancing force when an object is sitting on a surface the normal force, F sub n, and we don't know what that is. Right, so the convention is to add up all of the forces in the x and y direction. Okay, so we use the Greek letter sigma. That's a bad drawing. It's a Greek letter sigma. Add up all the forces in the x direction. There are no forces in the x direction, so that's equal to 0. Okay. Then we add up all of the forces in the y direction. Okay. That also should equal 0. There should be no net force because our turkey is at rest. There is no acceleration. And we know that since the net force is 0, we have 0 should be the sum of all of the forces. And here we're going to use the convention that upward directed forces are positive and downward directed forces are negative. So all of the forces in the vertical direction need to add to 0 because the turkey is at rest. So we've got a positive force, our normal force, okay, and then we've got a negative force due to the knife, and we've got a negative force due to gravity. So if we solve for this, we get the normal force that we're looking for is equal to the force of the knife, which is 2 newtons. We get the force due to gravity is 98 newtons. And so the normal force, whoa, that's really sloppy, is equal to 100 newtons. Okay, so in this case in particular, the normal force isn't just balancing out the force due to gravity, but it's also balancing out an additional downward force. Both of those forces need to be supported by the table so the turkey doesn't fall through and ruin Thanksgiving. All right, example 2 says, while you had your back turned, your dog got a hold of the turkey, pulled it to the floor, and is now dragging it across the floor with a force of 20 newtons at an angle of 37 degrees with the floor. Okay, so the dog is pulling the turkey along on the floor. The floor is now all greasy because of the turkey, and so we're going to consider the floor frictionless. Draw a free body diagram, and we need to find the net force and acceleration on the turkey. All right, so let's draw in all of the forces that we know. Okay, so again, drawing a dot in the middle of our turkey, we'll draw in the force due to gravity is again 98 newtons. We know that the dog is exerting a pulling force at some angle, and that's the force due to the dog is 20 newtons. Okay. And we know that there should be some normal force, right, because we're assuming the net force in the y direction is 0, because we are under the assumption that the dog is dragging the bird horizontally, not causing the bird to lift up above the floor. Now, it also says that this force due to the dog is at an angle relative to the floor, right? But that's hard to measure because we have to draw our forces coming out of the middle of the turkey. So what we should do is we should actually draw in our x and y axis, and we should draw we should draw in the axis parallel to the floor through the center of the turkey. And while we're at it, we can draw in our vertical axis through the center of the turkey also. Okay, so the angle, 37 degrees, is right there, measured with respect to the horizontal. Okay, so with that, we can start doing some problem solving. Now, just like with projectiles, we can only do problem solving along the horizontal axis or the vertical axis. So this diagonal force needs to be broken into its components so we can problem solve vertically and horizontally. We can't use this guy as he is. And so what we need to do is break him up into his horizontal component, force of the dog x. If I use cosine, 20 cosine 37 is 12 newtons. Okay, the vertical component, force of the dog y, 20 sine 37 is 16 newtons. Okay, and now that we have broken the force of the dog, its diagonal vector, into its vertical and horizontal components, we can squiggle through this force vector to say we have dealt with that. We have broken it into pieces. We no longer need to consider this diagonal part. All right, now we want to follow the same process that we did before. We want to look at all of the forces acting vertically and horizontally to see if it can help us solve for pieces or answer the question that we've been asked. Okay, so let's sum up all the forces in the y direction. We know, or we're assuming, that the turkey is not going to be lifted off the ground, so there's no vertical acceleration, And so if we add up all of the forces acting vertically together, they should add to 0. And so 0 should equal our two upward forces that are positive, the normal force, okay, and the force of the dog in the y direction. Okay, and then we've got a negative force, which is the force due to gravity. And I just realized I have my values mixed up. So the force of the dog in the y direction should be 12, and the x direction should be 16. So let me fix that really quick. Okay, so the eraser wouldn't work, so I just crossed out the values. So force due to the dog in the x direction should be 16 newtons, and force due to the dog in the y direction should be 12. All right, so let's put the numbers into our equation. So 0 should equal the normal force, which we don't know, plus the force of the dog in the y direction, which is 12, minus the force of gravity, which is 98. So when we solve through this, we realize that the normal force should be equal to 86 newtons. Okay, that is smaller than the force due to gravity, which is telling us that the dog, by pulling a little bit upward, is supporting some of the weight of the turkey, which makes sense. Okay, now let's add up all of the forces in the x direction, because our question really was find the net force and acceleration of the turkey. There was no acceleration in the y direction, but we were able to solve for the normal force, so that was nice. In the x direction, there is only one force that we can see, and it's the force of the dog pulling horizontally. And that has a value of 16 newtons. And so that is the unbalanced force. Okay, there's no force pulling in the opposite direction. So since it's unbalanced, we can call that F net. And it's acting horizontally. Remember, Newton's second law says F net equals ma. Okay, so we've got a net force of 16 newtons. We remember we solved for the mass of the turkey was 10 kilograms. And so we can solve for the acceleration. 16 divided by 10 is an acceleration of 1.6 meters per second squared.